Welcome, everyone, to this Professional Development Hour presentation brought to you proudly by the Atlanta Metro chapter of the Georgia Society of Professional Engineers, an affiliate of the National Society of Professional Engineers. Before we begin, we'd like to let you know that any opinions presented tonight are solely the opinions of the presenter and not that of the Georgia Society of Professional Engineers, the National Society of Professional Engineers, or any other of its affiliates. We certainly hope you will enjoy tonight's presentation, so sit back and relax, and on with the show.
All right, everybody, we're going to get started here. Thanks. Appreciate your patience being here with us. Our presentation today is actually a panel discussion. We have three panelists here, and the topic is engineering for temperature extremes. We have three panelists. I'm going to introduce each one of them just by name, and a couple of them are going to have a more detailed presentation that they're going to go through. So without further ado, our first panelist is Ted Stott. He's PE, and he is a project capital project manager, Oglethorpe Power Corporation. Our second panelist is Dr. Charles Calmbacher. He's a certified industrial hygienist, and he's a principal of Occupational Health and Safety Services. And our third panelist is Rish. He is a state materials engineer with the Georgia Department of Transportation. Please join me in welcoming our panelists.
All right, so first up, I would just like to give you a short overview of some of the things. No, it's only for the recording. Oh. So, give you a brief overview of some of the tests that we do at Georgia DOT, since I'm in charge of the materials and testing for all products that go either to roadway or structure. So first slide, please. So first off, you've got the biggest component in all materials that you generally think of, such as concrete and asphalt, which is your aggregates. Coarse, fine aggregates, all the types of sands, big rocks that you normally think of. They can be highly susceptible to freeze-thaw damage due to moisture intrusion or other physical properties of the aggregates. And there are some, we're very heavily for the AASHTO, but we also have ASTM tests and other ISO standards as well. But I reference the applicable AASHTO standards that we do for freeze-thaw for aggregates. We can talk about it a little bit more later if you want to. Next slide, please. Next up is concrete mixtures. There's been a big push in redeveloping a bunch of new performance-based standards for concrete mixtures. It's called Performance Engineered Mixtures, PEM for short. There's been a lot of change in the concrete mix design process versus being more prescriptive. The private sector was definitely ahead of us in this area, but states are trying to be a little more free for the contractors and whatever to do their own mixtures. And so some of the tests that are here I've listed are a bunch of them. The first up, our series is a giant overview specification that you could read if you have a subscription to read such specifications. It goes over a multitude of different tests that are the performance standards for different things such as freeze-thaw susceptibility, resistivity, lots of other chemical and physical properties of concrete. But first up, the biggest key point for concrete is always air intrusion. So you want to have air in your concrete to protect it from freeze-thaw, but you want to also make sure that the voids that are the percent air in the concrete are not connected so that water can't transmit through the concrete itself. And you also want to make sure that they're evenly dispersed throughout the entire matrix so that they aren't susceptible to cracking and other forms of deterioration. There's lots of new tests in that area. And then the big new test that we're looking at ourselves is a rapid freeze-thaw test. Normally, you have a very boring time of taking a sample, putting in a liquid suspension, freezing it for a long period of time, thawing it for a long period of time. And it takes weeks upon weeks for you to test one material. There's a new standard which has a little more automated method of moving the sample so you can do multiple freeze-thaw cycles in a day versus 1 or 2 a day, which would take a technician forever. And I know you wouldn't want to wait 6 months for someone to test one concrete mix design for your building that you're going to build. That would take forever, so there's lots of improvements in those test procedures. All right, up next is the last slide, which is asphalt mixtures. There's obviously lots of varying different tests for asphalt mixtures. It's the biggest part of our roadway network on a nationwide scale. Concrete is mostly for structures, but asphalt is primarily for roadways. We've got a bunch of different tests for determining flexural creep strength, which is basically how the material deforms over time due to a heat load or a freeze method. And then you've got air voids are also important for asphalt mixtures, just like Portland cement concrete. And then you have a bunch of different methods we use to determine what those density values are, which give you void ratio and everything else for asphalt mixtures, which are primarily based on a nuclear density measurement device, which is what's most widely used. And then we have some newer areas that we're starting to do a lot more of for non-destructive testing methods, dielectric, so ground penetrating radar and other forms of geophysics measurements are starting to come onto the scene. And we're trying to do, instead of just a spot test here or there, you can, with a GPR system, you can cover a wide mat of a roadway or a structure to get a much better picture of how the dielectric or density or other measurement that you're trying to correlate to it is throughout the structure. And so this is just a couple of tests to start us off with topics to discuss, areas of interest that people want to know more about, and maybe I can connect you with other people later. But that's the end of my presentation, and once we get to questions, we can talk more about these separately if needed. Thank you.
Hello, everyone. My name's Ted Stott. Like Jesus said, I'm a capital project manager for Oglethorpe Power Corporation. To kind of let you know a little bit about who Oglethorpe is, we're like the other power company in Georgia. Next slide, please. So, but we do cover a large area of Georgia. So everything it's supposed to be red there is our service area. And we're owned by all the EMCs throughout the state of Georgia, and we produce power for them. Go to the next slide. Our portfolio of power plants is quite large. We own quite a bit of different power generation facilities, but we only operate and maintain the fossil plants or the natural gas plants and the hydro plant. And where I work at the corporate office, I basically have projects primarily in the natural gas plants. And then, correct, yep, yeah, I had a long drive here. Next slide. So in cold weather, one of the style plants that we worry about is our combined cycle facilities. So our simple cycle facilities are pretty simple. They're a combustion turbine. You just fire it up, stays pretty hot all the time. Not much water in there. Our combined cycles, it's connected to a boiler and it's got a steam generator with it as well. And the challenging part of what we do is basically in our area, it only gets cold a couple of days out of the year. So to go about and protect these plants for continuous 100% reliability, we go through a lot of effort, which for most of the time seems like a waste of time, but a couple of weeks ago, it pays off. So these are our combined cycles. The one I've worked on the most is the one in the middle, the Bobby C. Smith Jr. facility, where we did about $7 million worth of upgrades on the heat trace within that plant. Now, why do we do it? Well, obviously, we want reliability. If you go to the next slide, please. So, part of it is that we are regulated, and one of the reasons why we have become regulated in this it's always been known. Heat trace has always been part of the design in the power plant, but we kind of neglected. And in 2021 in Texas, when they had the cold spell there, their blackout was, one of the major causes of it was the failure of the heat trace system, taking out critical instruments that are used to maintain or to operate the plant, and it just started taking them out and it cascaded. Heat trace is a method of applying heat to a pipe to prevent it from freezing. And I'll get into the different types and a little bit more of the detail.
You put a heat spiral cord around a pipe.
You'll see, a little more complicated than that. So we got regulated by NERC, and it was already in the works. The regulations were out there to ensure reliability of the bulk electrical system, but Texas kind of kicked it and got us going a little bit faster on it, to the point where they broke out cold weather events out of the EOP-011 into EOP-012. So go to the next slide. So when they instituted it, basically, what we go into the plant and we evaluate it, and basically we went through every P&ID in the plant, highlighted, what pipes needed to be protected, which ones didn't, and we set the design criteria for the plant on what we were going to design for. Basically, how far below 32 degrees is the plant going to get? How long will it be under that temperature? And then also wind ratings are also considered because it increases the heat transfer, in exposed pipes. And then we looked at, things like drains, pressure sensing lines, small lines, and then whether or not the system's able to be drained or recirculated during operation. All those things get put into consideration. Now, one of the things that there is an interesting cutoff point in regards to, and it's all economics, basically, when you can enclose one of these plants versus just keep it exposed and just heat trace it. Our Chattahoochee facility that I showed up there is enclosed, at least the steam turbine and the combustion turbines themselves. And it's a very nice facility, easy to work with. But for these older plants outside, we had to identify and do a complete comprehensive audit of the plant. Next slide, please. All right, and then we go into the different ways of preventing, the plants from failure. Basically, there's just administrative controls. Like I said, there's areas that we can drain while we're operating and keep the water in the pipe from freezing. We can just insulate it. That's also a possibility. Then we do heat tracing, and that's where we actually apply. We basically put a tape, which would be the self-regulating type cable, and we apply it to the pipe, and we tape it on there, and then we'll insulate that. But then we also have mineral insulated heat tracing, which is a higher temperature where we'll end up, it'd be like 500 degrees or more is what that would be good for. And then we also have for our sensing lines out there, heated tube bundle, which it's basically a package. It's the heat, it's the pipe, and it's the insulation, and we run it, throughout the plant because well, I won't get too much more into the detail than that, but we run a lot of it. So, and then we have instrument cabinets that basically house the instruments themselves, and then we'll also install in PLC control cabinets to monitor the system and also distribute the electricity to all the heat trays. Next slide. So these are the different types. The simple stuff's the SR cable up in the left-hand corner, and then you got the MI cable, which is a little bit more robust, and then there's the heated tube bundle there. Next slide. Here's some on installation. So we've put miles of this stuff onto the pipes. On the left is the MI cable. On the right's the heat trace. All that gets insulated. This is just during construction. Next. Here, an example of one of the instrument panels. You can see that's a pressure transmitter inside there. It's in construction. It's not completely done, but there's a heater inside there to protect the instrument. and then that heated tube bundle is over there on the right. That's the process connection point right there on the right. Next. This is one part of the project. We replaced the water lab at the plant, and from there, 25 samples were taken throughout the plant. We ran about a mile of heated tube bundle just for that project alone. Next. And then here's a picture of the control cabinets that are out there. It's basically it's kind of weird because it just looks like a circuit breaker like you would have in your house. But we actually have current sensors on each one of those legs, and we monitor all the time, and it'll automatically turn the heat trace on and off based on different sensors that we have out there, and it's also connected to the control room to basically give them an indication when one of these, like let's just say for whatever reason an SR cable gets pinched. And it changes the current draw from that circuit. It'll monitor it and just say, hey, there's a problem with that circuit. We got to go take a look at it. And that's it. And I can go on for quite a while on this stuff if you want me to. But it was
Gonna upset somebody, or we readjust the camera. No, I understand that, but I want to stand up because I'm missing half the room. I'm Chuck Calmbacher, and I'm a certified industrial hygienist. In case you wonder what that is, no, I don't clean buildings for a living. We work on the environmental health and safety aspects of the workplace, which can include climate, engineering, airflow. We cover quite a bit of ground. Now, the number of certified industrial hygienists, unfortunately, is fairly low. There are about 3,600 of us in the world. It's a worldwide certification. But there are plenty of other industrial hygienists that haven't been certified. The certification is sort of like the PE. It's had 2 12-hour days of testing, and it covered things from radiation, ventilation, airflow, radiation safety, radiation management, noise management. It's very comprehensive. But the point being is, one of the things I've been involved with is hot and cold exposures of people working in the field, which can include you. But it's also the idea of, how do I design a job, or how do I run a job and keep people safe? Now, I've worked everywhere from the Arctic Research Center in Alaska with the Army to the Amazon jungle in Ecuador and Bolivia, and the high altitude desert, Atacama Desert in Chile. Being able to keep people working without them getting injured is critical, and it needs to be part of design. That's the thing. If you work with CIHs, you often can save money, believe it or not, and also have less problems of implementing projects. We had, one project I worked on was with a company that made oxygen concentrators. And there was a lot of assembly involved in that. And the point was, they part of the design was that people never had to reach past a safe distance. Now, it sounds something silly, but the fact that it was designed so people didn't have to reach past things is we had very few injuries as a result. And you get the same things. I worked with someone, it was sort of an interesting situation because it was in western Illinois, and we were getting rid of soil contamination. We were doing the remediation using a rotary kill. And the rotary kill incinerator was high temp, and the snow was 2 foot deep. So we went from one extreme to the other. People working near the incinerator, I had to be careful that it didn't get overcome by heat stress or heat exhaustion or one of those injuries. But as soon as they walked away from it, they were now subject to cold injuries. And when you're designing something or you're going in to evaluate something or sending someone to do it for you, cold and heat become very critical. You go in and work in a processing line in a meat plant, you're liable to be standing in a freezer for 8 hours a day. And then again, you turn around and you have somebody working on a rotary kiln, they're liable to be exposed to high temperatures all day long. How do you work your design to prevent that? How do I keep the engineer or the operator away from the source of the temperature? How many of you have considered that when you've designed something? I was really happy to hear of the Association of Engineers that are interested in not killing and maiming people. That's a really good way to get started, But we can also include not injuring them, and it's possible. And that's, one of the things that they stress to industrial hygienists: get involved with the design. Because you can help someone design. If I tell you we can't do this, we have to do something along this line, I can get you to design it that way from the start, whether it be a table in the design that elevates or lowers according to the employee. All of a sudden we've got control of the situation. We can move people away from heat and cold. How many of you really think about cold injuries when you start? What cold injuries are there? No, there's huh? Well, before that we get chilblains. That's that itchy red stuff that you get in between your toes and fingers that it tells you you're heading towards frostbite. Then you get frostbite. You also have cardiac impacts where it can stop your heart if it gets too cold. Heat seems to be the big thing. Of course, a lot of things that are engineered are generating heat. They're either purposely doing it because of what their purpose is, or they're generating it because we have high voltages, we have motors that are operating things. And what are, yes, Bill? Oh, I thought you were, what are the heat injuries you can see? And these are things where if you've got people working in the field, you need to look at something called heat syncope. That's when people just get dizzy or complain they're exhausted and having trouble thinking straight. That's the first sign that heat's getting to somebody. Then you have heat rash. If you get heat rash, don't ignore it. That's telling you that your body is stressing from the heat. Then what is there? There is heat stress where people actually lose their ability to perform, think clearly, and they very often get dehydrated. Then we go to what's next? Heat exhaustion's next. That's where you have problems with your circulatory system, getting your body cool, because that's how it works. Your blood vessels open up and help your body radiate heat. So you get heat loss through radiation. And then there's heat stroke. And if you get the heat stroke, you've got a problem. That's where the cooling system of your body shuts down. All right, you actually have no more sweat to give. And that can happen from dehydration. It can happen from physiological problems. And your body shuts down. Just so you know, at best, 15% of people that go into true heat stroke live. The number is more accurately 10%. So designing equipment to prevent that, designing a work site to prevent that is important. And in case anybody cares and you're a project manager, OSHA has one of their points of interest over the past 2 years and this year as well is heat injuries and the reduction of them. So you need to think about it. You look at something called, I don't know, is anybody familiar with the wet bulb globe temperature? All right, we call them widgets. If your widget shows that your combined temperature is 80 degrees or above, you need to adjust your work schedule. Now, this started with the Army years ago. I don't know if any of you have seen the old swing psychrometers. Yeah, well, that's basically telling me my wet bulb index, which is telling me how much evaporation I'm getting off my body. Therefore, how much cooling my body can do. So, heat stroke is when your body isn't producing any more sweat. Heat exhaustion is when your circulatory system isn't adjusting to radiate heat. So if somebody is sort of pale and clammy, they probably have got heat exhaustion. If they're red and dry, they're probably having a heat stroke. And to prevent that, you adjust your work periods. You have shade for people to get under. Something as simple as one of those pop-up canopies. You have water for them to drink. If you're over 80 on your widget, you people should be getting a quart of water an hour. They don't have to drink it. You don't have to force them, but you want to make sure it's available. You may have something as simple as a sprinkler for them to walk through and stand in. But these are things that definitely going to impact your work production. Definitely going to impact the accuracy of your installation or repair. So these are things that I think engineers need to consider when they're looking at a project or looking to approve it. It's a whole critical issue at that point. Anyway, if you have questions more about the the job of a CIH and helping an engineer, please let me know. I guess we open for questions now.
I have a question. With the advent of conditioned air, have we lowered our resistance to extreme environmental conditions? I know I've worked at 120 degrees, low humidity, but we drank lots of water and we popped salt tablets like M&Ms, and we survived it, worked 12-hour days. I'm wondering, I've been in warm temperatures and couldn't stand cold temperatures. I've been in cold temperatures and couldn't stand the opposite. So as a people, and as a general thing, the question is, have we lowered our resistance to being able to survive under extreme conditions?
No, that's not really the case. What happens is you do get acclimated to it. I don't know. When I worked with the Army, I worked on Desert Storm and Desert Shield. I don't know if you remember that. And I freaked someone out. I was doing some training up at Aberdeen Proving Ground, and the fellow with me was a PE, and we were working together on a project. And the TV was on, and I was watching the troops. They were showing the troops in encampment, and they were playing volleyball and all. I said, next day or two, that Desert Shield is going to become Desert Storm. And that's all I can say at this time. The guy looked at me and says, what? Well, the next morning, the guy has my phone ringing at 6 o'clock, and he said, USOB, how'd you know that? I said, how'd I know what? He says, have you turned on the news yet? I said, no. He says, we now have Desert Storm. I said, the way I knew that is the Army planned for going to an area where they weren't used to the temperature. And when they started playing volleyball, they were acclimated to the climate so they could fight. And that was what Desert Shield was about, getting people located into tactical positions but then acclimating them before you tell them go fight. And if you do it, I don't know if anyone's familiar with Navy vessels called LHAs. We tease them, say, largest hotels afloat. They will carry 3,000 to 4,000 Marines on board, and they have the ability to take out, those hydroplanes and things to attack. But the funny part is that ship will put those Marines in an environment to which they're heading. So if they're coming from Norfolk Navy Base in Virginia and they're going to the desert in the Middle East, they're going to be living in conditions that are low humidity and high temperature. They'll be exercising, they'll be eating, sleeping, and everything else in that temperature. By the time they get there, they'll be more acclimated. If they're going to the Arctic, they're going to be living at 0 degrees or lower, so that they're acclimated to it. So yes, acclimation makes a big difference.
But in the Joseph, we are coddled. We have conditioned air here.
Right.
As a nation, is that not a bad thing? We are losing our acclimation to the outdoors?
It makes us more susceptible to extremes. Hmm? Oh.
Go ahead and ask it, Nathan. We put our dependence, we're coddled here. Are we as a people, as a nation, maybe losing our ability to live in a environment without that conditioning?
In some ways, yes.
I mean medically, I think we would.
Acclimation. If we're leaving our air-conditioned homes and offices, we're going to have to acclimate to whatever temperature we're going to before we can work comfortably there.
We better hope we don't have problems.
Oh, it is working. Okay. The idea, I kind of want to just tag along with Luther's comment. It's been said that the United States population has migrated southward. If we were trying to find the population center, it's in my 63 years, it's drifted southward, mainly because of this carrier and its friends. The guy who invented AC. And, you wonder, have we gone soft? I mean, this is just extrapolating on you. Have we? I kind of think we've gone a bit soft.
We've become.
I grew up in a house on, 7 miles from Lake Ontario in Rochester, New York. We didn't have air conditioning until my mother got very old and I was out of the house. Then they bought a 1-ton unit and put it in the dining room. My wife, same thing. She grew up a mile from Lake Michigan, about 80 miles north of Milwaukee. But down here, you don't have your AC running.
Well, I mean, that is something, we are acclimating ourselves to these things and get so used to being cool, our car, our house, our workplace, that yes, we have to, if we're going to work in a hot place, we need to get more acclimated. The move south is not just necessarily climate. I grew up in Hudson Valley in New York, near West Point, and summer came July 23rd, and you open the windows in your car in the house, and you didn't need air conditioning. That was basically it. Down here, people lived without that. You look at old houses, and they have a cook shed out back. Well, why did they have a cookhouse? Because who wanted to run an oven inside the house in the middle of summer? So you had a cookhouse, you went out there, did what you had to, and got out again. It's adaptive culture, but yeah, we're spreading our culture because, well, let's admit it, industry likes it here, and therefore the jobs come here and people move south. Because how many snow days do we have? I mean, I when I first came down here, my wife was from Jacksonville, Florida, and we got married. And I was working at Georgia Tech Research Institute that has this material group there. And I look out and there's some snow flurries. At the time, I owned this Chevy Blazer, 4-wheel drive and all. So I get dressed and I come out, my wife's in her pajamas, having a cup of coffee, watching television. So what are you doing? You're not going to work today? He says, no, what are you doing? I said, I'm going to go to work. He said, no, you're not. I says, why not? He says, the snow. He says, that's not snow, that's flurries. She said, no, where you came from, that's flurries. This is a major snowstorm. I says, oh, come on. She says, well, sit down, have a cup of coffee with me and watch TV. Well, sure enough, Georgia Tech was closed. UGA was closed.
My wife and I ridicule when we have storms down here. I remember the infrastructure of upstate New York. Rochester, New York, the downtown was built separated by the Tennessee River. They used to have gates on the bridges, open, and late at night, pedestrian traffic was gone. They open the gates and plow snow directly
into the river.
They can't do that now, but
See, where I grew up was near the Hudson. But they used to plow the snow into the Hudson.
Yeah. Okay. So where I work, near the end of last year, it's an asphalt road, and some of it looked like crocodile skin. So they went through, and in a few places where it was crocodile skin, they went and they dug out a little bit deeper, and they went and then they put in asphalt in those areas, and then they went and they put in a top layer of asphalt, maybe an inch or two thick, and they finished the project at the end of last year. So it is today is the 10th of February, and already there are some small patches where the asphalt, the new asphalt, did not adhere to the asphalt that was underneath. What can be done to prevent that, given that we've had freezing weather over the last 6 weeks?
So are you talking cold patch or hot mix?
This was hot mix.
So as long as they properly tacked the roadway, it should have adhered to it. So that is one thing that is a key for a lot of people here talk about bridges and buildings and everything else. And you were talking about proper installation. You're talking about supporting people so that it can be built properly. If someone doesn't put the layers together and they don't tack it well, then yes.
What is tack?
Tack is, here in Georgia for us, it's liquid asphaltic cement. There's also emulsion, which is a water and detergent mixed with asphalt that it breaks, so the water evaporates, and then you're left with the AC on the bottom. But primarily, at least for Georgia DOT, most of our tack is liquid asphaltic cement, and it's hot applied a couple hundred degrees. Now, another thing, people are talking about differences in regions. There's other states where up north, which doesn't make sense to me, where they're maybe more concerned with heat-related injuries. Tack is 300 degrees. It can easily burn someone. So some states have had lots of problems with that in the past, so they are emulsion only. So it's not hot when it goes down, and you don't have to worry about damage to workers and everything else like that. But it's a very, very intricate chemistry, because you need to know the humidity, the temperature, how it's going to change throughout the day, and everything else, and the right detergents and other additives has to be mixed with it so that the water does evaporate. Because if the water doesn't evaporate completely when you then put the asphalt on top of it, you trap the water in underneath the layer. But the other thing that's normally the issue with whenever you're patching small areas and then putting something on top, if you haven't properly secured or milled out the entire width of the roadway, then it will come apart easier when you do it. So when we try and do a roadway, we try to do full width of the lane versus, a patch here, a patch there, a patch here, a patch there. And you've seen a lot more locals where even if they do a patch, it may be short lengthwise of the roadway, but it might now be full width versus strips, because it's much easier to get a uniform installation. The paver is 8-10 feet wide, so it's naturally easier to do that versus a smaller paver where when you've got when you're placing the material, you've got a roller. It's a static or vibratory roller, and those have certain widths. And so whenever you get near the edge and you're bridging different materials, you've got a hard surface and a malleable surface. You have to make sure that the operator knows exactly how to ride both sides so that it properly compacts. Because even if it adheres with the liquid, if it isn't densified properly, it'll ravel and come right back out.
Are there quality assurance and quality controls?
Yes. So for us, the quality control is the contractor. Quality assurance is us and our inspectors and everything else. Other states have different roles and different measures. Certain things we can take contractors' test data for acceptance. It depends, and you have to have different levels of statistical validation to make sure that the tests aren't just being written down. They're actually be performed to make sure that they're not lying or whatever for quality assurance. But there's far less people in the workforce in all industries, but especially in transportation. And so there's fewer and fewer inspectors out in the field to witness everything else, which one thing the industry is trying to, like, I briefly talked about dielectric for density. You can get much more data. You can cover an entire lane all the way the length and width with tons of data to give you indications of, oh, it's here or there. The old school test methods are it's a nuclear density. It's a rod driven into the material with a nuclear source and then a measuring device up in the back of the instrument. And that's a point data. But a lot of things that we're trying to get better in the industry with non-destructive testing is, one, it doesn't destroy, it's non-destructive, so you don't damage the new material. But also, it's easier to get tons of data quickly and everything else. Some new things which we currently don't do yet in our state, but most up north do, is thermal profiling. So like a FLIR camera, for measuring heat of an object or whatever, they can strap those onto a roller to make sure that the uniform temperature, to make sure the material hasn't segregated. So like, has anyone ever worked in here with a quarry? So like you have giant piles of rock. Well, you know that there's an angle of repose and how they drape off the sides of the pile. If you don't scoop the right side of the pile, the large particles end up over here, small particles end up over there. Same thing can happen when you dump asphalt into the back of a dump truck. If you don't dump it in the truck properly, then you can get the large particles over here, small particles over there. And then when it gets in the paver, now you've got weird, it doesn't look uniform, and it will come up quicker because it's non-uniform. It's supposed to be evenly distributed so that the material stays together in the homogeneous mixture you want for it. I started off in geotechnical back when I was early in my career, so I studied soils for foundations and stuff for roadways. Same thing with soils. You have well-graded or poorly graded materials. The distribution of the size of the particles makes it easier to compact and makes it a better material. So there's lots of pieces that go into the puzzle, and also just workmanship and time. If it's patched here and there and then they just blade something on top of it, they may not care as much as if you're building a brand new roadway or a brand new building. I don't know about y'all's industries, but when you're building a brand new, really big building, you might have a little more effort into making sure all your I's are dotted and T's are crossed versus like you're doing a retrofit. You might look at only the things you're supposed to look at versus the entire piece of the puzzle when you're building it. And retrofitting is different than building a whole brand new product. And the methods you use to modify a building or modify a roadway, I would think very, very greatly depending on if it's a brand new piece of structure or whether you're retrofitting something. And it could take a lot more time or money to retrofit something versus building a brand new building, but cost benefit, all those fun things, all the math.
Yeah, actually, one of the weird things I've dealt with is that a lot of these plants were built at around the same time. There was like a heyday where they were building these plants, all over the place. And what I find when we take off the installation is that the original installation wasn't done to the design because Because one of the things I hear is that the design is always correct. I mean, it's like it is, it is. I mean that's part of what we do, but it's getting it installed and making sure it's installed to the design. That's the trick. And basically what I found in this heat trace and protective pipes is valves would not be wrapped the way they were supposed to be wrapped, or they'll just come up short. So there's a piece that's exposed. It's that type of stuff. So when we go in now, it's like I go through a pretty strict quality assurance, quality control, making sure stopping points are there throughout the process to make sure it's done the way it's supposed to be done. So,
Ian, you had mentioned paving materials, concrete, asphalt.
Yes.
How about some of the newer materials or geosynthetic fabrics?
So do you have geosynthetic in your portfolio for your 401k, or are you just asking in general?
A geosynthetic fabric company was a potential client of mine. It didn't materialize, but
Are they made in Georgia?
yes,
Are they grids or fabrics?
fabrics,
Oh, okay.
sheet or quilted.
So most of the fabric or grids that are used for our line of work for Georgia DOT are for stabilizing existing embankments. Stuff that I dealt with a lot before. So like you've got a roadway that's coming through here and you want to minimize the footprint for disturbed land area. It's either going to be a wall or a slope. And the slope could be a normal 3-to-1 slope, that you can mow very easily to take care of it. Or you could need to bring it in so that you don't have to buy any additional right of way. But you don't want to do a big expense for a very expensive wall. Then that's when geosynthetics such as fabrics or grids would come into play, and you'd reinforce at different layers depending on the design required to steepen that slope. They're not used a heck of a lot. There are some other types of fabrics which can be used in the pavement structure. Those are currently being studied in certain areas. NCAT, the National Center for Asphaltic Technology in Alabama, is a big research area which some of those items are currently being looked at. But geotextiles are mostly used in construction situations such as erosion control and stuff of that nature is the highest use of geosynthetics. Some of them are used behind walls depending on what kind of system it is. Certain walls, when they're built on a project for a Georgia DOT project, are designed by the contractor. So we just say it needs to be this shape in general. You submit a design to us, it's reviewed and signed off by a PE and stamped and licensed. And then that design is not dictated based on us what the pieces can be in, as long as it meets our specifications. So it could be reinforced with grid, it could be reinforced with fabric, it could be reinforced with steel. It just varies depending on the type of design that the contractor got.
Are there temperature implications?
Generally, I would say no, because they're in the ground, in the earth. Most of the stuff is protected by a roadway or earthen embankment. Fortunately, here in Georgia, unlike Michigan, upstate New York, those areas, we don't have a very big freeze-thaw depth. Some of my friends in Pennsylvania have shrink-swell soils that are frost-susceptible, and Texas has swell-susceptible soils that whenever it rains, they have giant rises in the roadway because something didn't have any moisture in it, then it did, and it swelled 200 or 300% of its normal volume because it now has water taking up the void space that used to be air. So lots of different states, lots of different regions has varying different issues with their soils and the freeze-thaw depth. I had the experience of being on a project where someone was talking about Minnesota, and they were like, oh, they had their gauges to measure 6 feet down because that's normal freeze depth. And then it got really cold for a whole month straight, longer than they thought it would, and they ran out of gauge because it maxed out at 6, and the reading kept saying 6. They're like, well, we know it went deeper than that, and they couldn't tell what it actually froze to. But in Georgia, generally, we don't need a lot of protection from freeze-thaw. As climate change happens and things shift differently, hot or cold could differently depend on what's going on. We had 2 big recent snow events. A lot more. It affects road maintenance a lot more than underlying structures.
I've noticed at intersections ripples in the asphalt from braking.
Yes, correct.
And I suspect that would be more susceptible in hot weather.
Yes, correct. So depending on the level of the roadway and the amount of vehicle traffic and the weight of the vehicles on it, we have different mixtures that we use for the roadway. Some of them come with a polymer modified asphalt, which is much stiffer and can handle much higher heat temperatures. We also have certain testing procedures that we do now versus what we used to do in the past, where we test the asphalt mixture in a hot water bath with a constant loading system on it to determine the rutting, which is what you're talking about, the rutting of the surface. So the mixtures are designed to not rut. But as you know, not all the roadways are Georgia DOTs. Most of them are counties or municipalities. But when we do have problem areas with heavy truckloads in South Georgia, we have actually milled and inlaid the intersection with concrete, because concrete is not susceptible to rutting. It doesn't deform in that manner. So some intersections you might find in problematic areas in South Georgia might have an inlaid concrete surface as opposed to an asphaltic surface. Anything else?
Well, I'm sure there are many more questions, but unfortunately we've got to go. Yeah, time flies by when you're having fun. Big round of applause for our panelists. Thank you. I am going to apologize profusely because we have speaker gifts that are sitting in my living room. So if I will get your addresses afterwards, I'll make sure that you get them. All right, folks. Thank you again. I want to make sure that everybody signed in.
We hope you enjoyed this presentation given at one of the Atlanta Metro Chapter meetings of the Georgia Society of Professional Engineers, an affiliate of the National Society of Professional Engineers. To find out more about us or to join us, check us out at gspe.org.